Right. So in the first session, we have discussed about what is the NVIDIA networking is and what are the products we have or the NVIDIA offers to the data center. Then we're gonna take a look how these network devices looks like, right? And what are their CLI and what are the syntax they supports. So I do have one this topology where we have some devices, and these are the leaf and spine, which are the NVIDIA GPU based switches, uh, which which is a predefined labs in the NVIDIA. You can even access from the NVIDIA website, right? So if you go to the NVIDIA website and search that NVIDIA uh, Air, that's where you can directly access these devices, right? Now, so since I have these devices, if you go to here and should be NVIDIA Air somewhere here. If I go back, yeah, NVIDIA Air. If you go back here, right, you can see that create digital twins where you can access directly NVIDIA lab where they have predefined or pre-configured labs. You can access at least for the hands-on what is going on, how the these spectrum switches looks like, what is their OS is. So since I have the labs, I have created my own labs. You need to have organization access to in order to access this, right? This is the lab I have. Okay. And on this lab, this is the switches and routers are connecting to each other, right? These are the logical, right? And this is the physical, how it looks like currently. Okay. You can see the nodes, how many nodes you have here, all the spine switches, router switches. You can directly console these devices. You can say they will link also how these links are connecting to each other. But our focus is not to discuss how the connectivity is. My focus is what and how the OS looks like. So currently, if you'll see that the Comulix OS is running on all the switches, and the version is 3.7, and some of them are different version. Okay, so let's see. If you see that the spine switches, where are these are some servers. Sonics are some internal servers. So if I go to the spine, this is the OB switch, which is fine. Okay. So if I go to the demo market, okay, in the demo market, you can launch there are various type of labs, right? It depends on what exactly you want to do it. I would say that log in the first, the introduction lab, which you prefer to see that because these most of the labs are already configured. I would say that start with this one, L2 VPN layer 2 extension, if you want to. Okay, you can figure it out. You know what all the details you have, layer 2 extension, BGP, what exactly is running in the lab. Okay, because I do have already this lab uh, logged in. Let me um, open the devices one by one. So if I go to the nodes, okay, in the node, if I go to the, for example, leaf one, okay, in the leaf one, it will give me the console. It is in there connecting to the console. And let me see that what is the username password I do have. A user Ubuntu NVIDIA, that's fine. What I can do here is I can go to the OB management server. Then I can try to log in these leaf and spine switches, but this should be able to allow me to log in. So if you see that Komulish is the username, password is, let's see if that allow me to log in. This password is not working or what? Komulish. If this doesn't work, then I might need to log in through the OOB server. If I go to the OOB server now and do that connectivity the way it is asking, it says the SSH to the leaf this command. Okay, I have to log in this one also, which has an Ubuntu and NVIDIA is a password. Ubuntu. Nvidia is my, this is the console server. So if I show you this topology, how this topology looks like, look here, this is the topology. I have one jump server, which is where all the devices are connecting from that jump host. Okay, so treat that as that kind of, oh, sorry, Nvidia. Nvidia, Nvidia. Uh, Let me fix that password. Then I resume the video. All right, so I have now my leaf switch login. Okay. Now, what is the syntax and how you can figure it out? What is the syntax? The syntax which you want to run anything on these devices is always start with the NV. Okay. If you want to say the configuration, say that NV, NVIDIA, NV means new, which is a command syntax for the Linux, for the NVIDIA Linux based switches. Okay. If you want to check the configuration type, NV config show. That is the command where you will see that all the, if I say the NV and double tap, in the double tap, you will see that what is showing that show command. Okay. So I can say that show, then double tap, you see that a lot of options are coming. What exactly you want to see that? I want to see that configuration. Okay. Wait. NV, sorry, my mistake. NV config show. Show me the configuration of this device. So see there what configuration we have. We already have that lot of other configurations. This is the NVUE, which is the my version of this switch is Cumulus Linux 5.13, which is the Linux base. This is the lab which they have created. Okay, and this is the VLAN which we have created, which called that VXLAN base. Okay, this is VNID. These are the EVPN configuration, and this is the interface configuration, bond configuration towards where? Towards the these switches. You know, we have you see here between the switches also we have bond interface, which is a port channel running. And if I see that this is the MTU size on the link, this is the bond interface member we have. This is the management interface and IP address configuration. This is the loopback or the peer link, which we have. When I say peer link, so in the Nexus we have BPC, right? Here we have a MLAG. MLAG has a peer link statement which run with the 4094 VLAN. So MLAG, if you know that your Arista switches and Aruba switches, these switches supports MLAG. Even Cisco's old version of the switches before stacking, they were supporting the MLAG. Okay. And if you see the NV interface configuration, if you know the VXLAN, how VXLAN work, this is the VGP configuration. This is the, NTP configuration we have. So this is the like the basic of all the, how this works. Okay. This is the current version, all these things. All right. So if you want to check the like, so sorry, NV. So if I say the interface, show me the interface of these switches. See here how many interfaces we have. So in NB switches, we call that bond interface. Okay. And also we call that these switches as WP interface. Okay. And that's where just like a so CDP neighbor, so LLDP neighbor, you have a so NV so interface, you will have all the details in a single command. What is the IP address of the local? What is the status? What is the remote device connecting to it? What is the IP address of it? And yeah, so currently we are running the dual stack IP4, IP6. Okay, that's where we have what interface being used for the MLAG. So this is all the details. Okay, now if you want to check the more NV show, you see here EVPN. You want to check EVPN. This is the EVPN configuration. So it's like a so you have to just type so then a statement. If I say so router, see here how many routes and routers we have, what currently is being run on this device. So MLAG, what is the MLAG status here between the MLAG, which devices we are forming. So MLAG is, it means just BPC is running between the switch 1, switch 2. MLAG, you can say that is a BPC, active or active standby. Okay. So this is the status of the devices. What is the current status between the two switches? If I show this, so services, what are the services we are running? If I go for the services, you will see that a lot of our services are disabled, a lot of services are being enabled, a lot of services are being already enabled. If I see the system, show me the system configuration. So this is the uptime of the system, just like a platform or so version you run that. Just this is the same time. What's the current product name? What is the current version you have released? 5.13. We have what is the when was the last build we had? What is the current memory and free space and all these details. Okay. And if you want to check that, so VRF label, how many VRFs we have? If you see that these are the VRFs which we have. Here also we have two different VRF, default and management VRF on these switches. Okay. And since these are the virtual boxes, not the physical boxes, that's the reason you do not see that the platform label details, right? But if you have physical boxes, the command will be same. A few things will be maybe different. Okay. If I say the NV interface, this is the VXLAN interface. What's the status of it and what exactly is running? What is the source and MLAG is running on that? What is the MAC learning is disabled or enable, off suppression is on or off? What is the MTU side? What is the flood and learn mode, head and replication, which is your flood and learn mode of the VXLAN? So yeah, so these are the things you can, if you want to configure anything, right? If you want to configure anything, for example, VLAN or anything like that. So the command start with the set command. If you see here, this is the command which we have. Okay. Uh, let's see. NV configuration. I have, this is the command. Okay. So the command which I pasted over here, you see here, the command says that show me the configuration which or syntax which has been done, saying that NV configuration, show me the configuration command which we have run. Okay. So if you want to run layer 2, layer 3, this is the command. NV you have to type, then set. If you want to configure interface, then MLAG enable, bond. If you want to run the VLAN or management interface configuration, this is the configuration of it. Okay. If you want to configure DNS or anything like that, for example, here, let me configure one DNS. Sorry. If I say no, if I say the NV set, what was the configuration we were doing? Services. In the services, what other services we have? If I double tap, you will see that DSCP, DNS, NTP, all this we have. So I will configure DNS. Then I will see that what was the IP? DNS management server. If I say that DNS management server, and I can type like 2.2.2.2. See, created. Now, if I run here, this entry should be visible over here now, where that entry went. It has overwritten something. Yeah. So that's how you configure it. I will be showing this configuration in a broad when I will do the practical end to end. Okay. And yep, this is all about basic of the configuration, how you check that, this is a Linux syntax. If you know the Linux, that will be very helpful for you to understand what is going on and how all these things, how do you check the BGP neighborship. So VRF, if we say here, look here, these are the BGP neighbors. If you check here, what command was, so NV so VRF default BGP neighborship. Okay, how many prefix been learned and sent, what is the address family we have, what is the message status, all these things. So it's not that hard, but if you really want to understand and learn these things, then we have to learn about the Linux. Without Linux, it won't be possible to check anything. If you see that, if you want to check that routing table, look here. This is how your EVPN routing table looks like. Okay, BGP routing table or generic routing table. If you want to check ARP, you can also search up like ARP. If you want to check the EVPN routes, and this is the EVPN routes you have. So if you want to check SNMP, this is the SNMP configuration, and even you can check the so running configuration of the SNMP. Okay. If you want to check the syslog of the server, for example, something is going on, you want to check the syslogs, you can always check the syslog. Okay, I don't want to touch that for now. The other devices, other than the uh, leaf switches, because there are GPU-based Linux servers which are running. You will see that BGP checkers. So it will give the entire details: how many routes fail, how many, what is pass. This is the status of the BGP. How you check that? Okay. And if you want to check like MLAG, MTU, NTP, this is the command network NetQ. Then you will check that what exactly you want to check. NetQ VLAN. If I type here, okay, NetQ VLAN, I will say the VLAN. Show me the VLAN. How many VLANs have been and what is the status of it? Saying that these are the status of it. There is no VLAN. Just NB is present. It means VXLAN is present on this. If you want to check that if there is any status between the source and destination, if there is any issue, if you see that net queue trace, you can see that this source from this destination from this source, show me the details. It will give you the entire path of the details. Okay, what is going on and how it is flowing. Even it will give the hop by hop detail here, which is way better than the our traditional devices. Each hop, if you see that this kind of trace route details, you can figure it out or find in the Cisco ACI. So since this is a leaf and spine based architecture, you will see the most of the outputs are being matched to that all the other vendor design also. Okay, if you can run the automation also, it depends on which I will be showing in the next session. So this is how you run your devices. If you want to check the spine switches, I can log into the spine switch console. See here, come on. It takes a lot of time because this is a virtual lab. All right, so I will say that no, not com. I want to press the wrong, so it can choose formulas. Then I will show that this is the password which we have. Let's see if that copy paste work. Yeah, fine. See here, this is the spine. So if I see the NV, so then I can show that system. Okay, this is the exact same Linux machine which we are running. We have a kernel image. We have a OS image, which is a Linux based platform. If I show that configuration, so config, so NV so config NV. This is, we see the EVP and everything is running on these devices also. And it says that Nvidia Cumulex VX machine. Okay. This is the This machine is just for the virtual machine designed for the like prototyping and just to check that what exactly and how it exactly it works. Okay. And if you want to check the servers, because there are firewalls, there are servers which are connecting to these devices, and these servers are GPU based. Okay. Or you can say that they are Ubuntu, but yeah. So to give you that the feel how the field works, how it works, this is how they works. If you check that how pings works through it, so there is server one in the topology. Let me open the server one and try to ping. If you show the topology, this is the server one. Okay, from server one, if you try to ping somewhere in the SBI, how the ping works through it. Uh, Let me show you this. If I open the server one, where are you, server one? Okay, this is the server one. Okay, if I open this, it has another password. So password for this one will be the same. Cumulix, then password is I am not sure if this is the right password. Yeah, so because this is the wrong password, if I type less, come on, Ubuntu Nvidia. Yep, here we go. Now, if I try to ping from one place to to the gateway, which is sitting in the ACI, not in ACI, sorry, Nvidia leaf switches, SBI we have. Look here, it's pinging. So if I go to the leaf switches here and check that and what this subnet belongs to. Okay, if I say that NV uh, conf so interface. See if you see that where they belong to. Paste. It belong to somewhere in the SVI. If I see that, so sorry, NV, and so where this route server one is connecting. So let's see, server one is connecting to the SWP1. Okay, our device. And if I show this SWP1, this is the where the server is connecting. This is the pure layer 2. This is pure layer 2 we have. If I say that interface pipe grep, if I say that SWP1, so SWP1, this is the server which where we have connectivity, and this is the layer 2, and IP address is not there, so IP address may be available. So this is the pure layer 2 to layer 2 connectivity. So let me see that from this server we are trying to ping uh, let's see. If I say here, look here, this is where we have tried to ping, right? Saying that to check layer 4. Okay, so this is the server 4 connectivity, server 4 IP address, which we are tried to ping. And the server 4, since the ACI act, our NVIDIA leaf and spine is acting as a pure layer 2, and it is extending that VLAN between the switch 1 to switch where the server 4 is connectivity is switch 1 to. If I say that this is the server 4. So server 4 is connecting us leaf number 3, and leaf number 1 has a server 1. And that has a connect layer 2 extension between using the VXLAN. Okay. So if you see that here, this is the switches, and if you go to VXLAN, we do have a VXLAN, and that VXLAN must be forming the terminal with the leaf number 3. Okay. Now, if I open this simulation, if I see that, so NV, so interface, you see that leaf 3 and 4, everything is connecting by the spine switches. Okay. And if I say that, so, and we, sorry, and we show routers. And if I want to check the routing, um, I don't want to check the routing. I want to check that EVPN. I will say that EVPN route advertisement currently is off, which is fine. I can say that EVPN on the leaf 1 because EVPN will have all the routing which contain the layer 2, sorry. I will say that NV show EVPN route advertisement. This is off. So I want to see the route of the EVPN. So command is to grab that EVPN advertisement. Though also we have VLAN created, and VLAN has this IP address. I think this was the IP range VARP. What was the IP we are trying to ping? 10, huh? 10 is, yeah, this is the VARP. VARP is like, if you know that Arista switches are having a VARP, which is it's like a virtual IP address across the sites. You can see that. Um, so config. This is the like just like a stretch VLAN, okay? But here stretch VLAN is not been configured, so it's a pure layer 2. But if I show you this, yeah, so we need to configure the stretch VLAN in order to see this kind of things, VARP for VLAN 10. Because currently it's a pure layer 2 to layer 2 communication is happening. If you want to layer uh, 3 configuration on the devices, then we have to configure this command. Okay. In order to configure this command, you have to run a few these commands. Okay. Because VARP must be enabled first, then state should be up, then you configure these all the commands to accommodate all these things. Okay. Now, if I run this command, I should not have any issue because these are the border switches which are having this configuration. I should not be doing it, but I just showing you this how this should work. Okay, that's fine. I need to do not need to copy entire thing back to back, but yeah, this is how you run that. I will be showing you the end-to-end from VLAN creation to the VXLAN and MLAC, how MLAC works, all these commands I will be showing you. But yeah, this is, I just wanted to show this how the graphical interface looks like, and this is just a Linux-based platform. NVIDIA syntax, if you, NVIDIA devices, if you really want to learn, there's two options. You learn by the Linux command line, or try to operate these devices using some tools, Ansible Tower or Python SDK or Postman, any of these tools, because these are the tools which can help you to do all the uh, X configuration of these devices. Okay, so I am starting the NVIDIA course, which is associate level. Okay, so I will be recording few of the sessions and uploading over here to make you guys more aware of NVIDIA products, how NVIDIA product works, and how we can learn these products from the our experiences. And yeah, there are a couple of like NVIDIA courses available freely in the NVIDIA site itself. You can always, uh, get that NVIDIA courses from the NVIDIA website itself. If you search here, NVIDIA network certification, so it will directly redirect it. It will directly redirect you to the page where it will have all the InfiniBand switches. With this, the in-band switches, InfiniBand. It's nothing like anything special on this. Okay, and but yeah, uh, if we go to network devices, yeah, these are the, if you see that these are the couple of the courses which they have. Okay, they have an associate level, they have professional level courses which can help your career to boost for the AI networking site. Okay, thanks for watching. We'll see you in next session.